Hi, my name is David Nataf. I'm a graduate student at The Ohio State University Department of Astronomy. In this coffee brief, I'll be discussing our recent paper, Detached Red Giant Eclipsing Binary Twins, Rosetta Stones of the Galactic Bulge, co-written with Andrew Gould and Mark Pinsonneault. One of the most fundamental problems in Milky Way assembly is the mean age of the galactic bulge, as well as the galactic bulge age-metallicity relation. This problem is not currently solved, as there are several contradictory and competing claims in the literature. Researchers who analyzed the bulge using CMDs and fit isochrones to the bulge conclude that the bulge is almost entirely a metal-rich population due to the absence of bright main sequence stars. Conversely, researchers who analyzed the bulge in the spectroscopic plane using microlensed observations of dwarf and subgiant stars conclude that the metal-rich stars in the bulge are on average approximately 6 gigayears old, with many of the stars being as young as 2 or 3 gigayears. Nataf and Gould 2011 pointed out that these two claims can be reconciled if one uses helium-enhanced isochrones rather than standard isochrones, as this shifts how stars of a fixed metallicity appear on a log-G TEF or standard CMD, and thus how ages would be interpreted from observations. Can these different claims be tested? If we now look at figure 6 in equation 5, we will see that these three claims make three very specific and distinct predictions about the mass that should be observed on the galactic bulge red giant branch as a function of metallicity. This is because the predicted mass on the red giant branch is a decreasing function of both increased age and increased helium abundance. If the bulge has a young metal-rich component with standard helium enrichment, shown in red, at the highest metallicities, the mass on the red giant branch should be about 1.4 solar masses. If the bulge is old with standard helium enrichment, shown in blue, then at the highest metallicities, the mass should reach about 1.15 solar masses on the red giant branch. On the other hand, if the bulge is old and heavily helium enriched, then the masses should be substantially lower. In black, we show the curve for delta y over delta z of 3, and we see that the highest metallicities, the masses drop below 1 solar mass. Devore 2005 measured the parameters for 10,000 eclipsing binary stars toward the bulge in Opaltooth data. We combed through this catalog and identified candidates with physical parameters such as period, color, and density corresponding to detached red giant eclipsing binary twins. We showed a 34 gold sample candidates in red and a 248 silver sample candidates in green on figure 1 on the left. We show them on the color magnitude diagram on the top left of figure 1, and we see that they're primarily on the lower part of the red giant branch. On the right, we show some of the OGLE-2 eclipsing binary light curves for the gold candidates, and we can see that they correspond quite clearly to eclipsing binary stars. These 30-plus bright stars, with their well-identified periods and phases, provide an independent means to test the recent claims of the galactic bulge age-metallicity relation, and to do so with extremely great precision. For more information on potential applications of these stars and the stellar models we used for analysis, please check our paper submitted to Acta Astronomica on March 24th and posted on astro-ph on March 28th. Thank you.